Good afternoon, everyone. Welcome back to our seminars after a little hiatus there. Our speaker today is Nicole Raineault from the Ocean Exploration Trust. She got her bachelor's from the University of Maine in marine science, her master's in oceanography from Rutgers, and her Ph.D. at the University of Delaware in geology, which is where I met her in Art Trambanus' lab. So now she did her postdoc at URI, and now she's working for the Ocean Exploration Trust with the Nautilus as the Director of Science Operations. So I'll hand it over to Nicole.
Thanks everyone for your attendance on a Friday afternoon. Promise lots of pretty pictures, and what I'm here to do today is hopefully explain to you a little bit about our program and how we operate. I'm sure many of you are familiar with NOAA's Nautilus Explorer, which is another exploration vessel. So today I'll talk about the EV Nautilus, which is operated by the Ocean Exploration Trust, give you some idea of where we've been, where we're going in the future, and how you can become involved with us. This is the ship, Nautilus, and this is also a talk to encourage many of you to become as involved as possible. So obviously a ship, Nautilus is heavily using telepresence to involve people from shore, but I like to get people out on the ship. And as someone who suffered from seasickness, and I recognize this very early on, I want to also encourage people who perhaps have not gone out to deep sea exploration because of seasickness to stick with it. It's very ship dependent, and though I've gotten seasick on many coastal vessels, I was a beach researcher in my early research days. I love going out to this deep sea, do deep sea exploration with the Nautilus and find that things are just fine once you're out there. So an outline of my talk, a program overview really, who is the Ocean Exploration Trust? Again, how do we operate? Some cruise highlights. I've squeezed a couple of those in from our seasons. We've been operating since 2009 with the Nautilus. Talk about our upcoming season, which is starting in June. And then the future expeditions when we're looking to get out to the Pacific Ocean and beyond. And some opportunities, again, about how you can become involved on land and offshore with us. So the mission of the Ocean Exploration Trust. I wanted to break it down for you so that you can see the various things that we're trying to do. The first is to go to unexplored regions of the oceans. This is different than what typical research vessels do. So you think of UNOLS vessels, typically scientists are applying to NSF for a project that they have some data around, knowing that they're going to go there and perform a set of experiments or do something that will produce results that are publishable. We do something that's a little bit more, or quite a bit more exploratory, and really, I think it's a benefit to the science community because we're collecting data in regions that you couldn't get funded to go, and we hope to allow other scientists to go there. We make all of our data freely available. We're publicizing our expeditions over the web via telepresence so that other people can get excited too, and use our data to write grants to go back out to these unexplored places. To do that, we also aim to conduct scientific research to the highest international and academic standards. It's something we've been increasing the data in the wet lab facilities on our ship. We just recently had a multi-beam system put on the ship so that we can truly go into uncharted waters. And again, that goes towards pushing the boundaries of ocean engineering, technology, education, and communications. Our ship uses remotely operated vehicles as its primary platform for sensors that scientists can bring aboard whatever their sensors that they want to integrate. So we've had integrations of things like mass spectrometers, these instruments that measure the flux of gases venting from the seafloor, whatever a scientist can dream of. We work with them to try to integrate it into our vehicle. And also with the communication side of things, because we're using satellite telepresence to get all of our exploration out over the web and over these exploration command centers, one of which you guys have here in your the room with the geo wall. You can communicate directly with the ship, so we reach scientists on shore who can also help us with our exploration. And again, so that goes to this other side of sharing our expeditions, not only with the public through our Nautilus Live website, which I'll show you, which is streaming video live from the seafloor 24 hours a day while we're out there, and answering questions from the public, but also reaching out to scientists. We can only fit so many scientists on ships. The Unault's vessel is shrinking, and it's also only moving into more coastal waters. They're smaller vessels, so it's really important to be able to engage as many scientists as we can with these few vessels that can get out to deep sea, and we do this via the telepresence that we have. So a little bit about the Nautilus. The Nautilus was an East German oceanographic vessel built in 1967. It was acquired by the Ocean Exploration Trust in 2009. We actually took ownership of it just this past year. And it's 64 meters in length. It could go to sea for about 40 days at one stretch. Normally we're out for a week or two between port stops to trade people on and off the ship. Its cruising speed is 10 knots. We have about 31 science team people on it during our expeditions. And when we talk about the science team, we're talking about our interns. We bring educators on board to communicate through our website to the public and through our studio, which I'll show you, to science museums and aquariums. Our engineering team, so our ROV team, and all the scientists on watch. So those are inclusive in that 31 number, and then we have 17 crew members who actually run the ship. Cruising speed of 10 knots, that's what we survey at as well for multi-beam. We could go up to 12 knots if we're running from someone. And we have a DP system, which of course is very important for doing this ROV work where you need to be stationary. The ship has undergone a lot of upgrades since I first started aboard the ship in 2010. One of the things I should show you, this container, this is a double wide container on top of the ship where it's the operations center for all of the exploration. We do all of the operations. So when you're on a watch, which are typically 2 4-hour watches a day, you're sitting in that control van. We have a row where the ROV pilots and navigators sit, and then the science row in the back, which is 3 people at any one time. And so when you're not on watch and you want to know what's going on from the seafloor, you're sitting in the lounge, which now looks like this. It's quite an improvement. So you're actually able to see the ROV video streaming from the seafloor in this lounge. You're able to see the data screens, things like navigation or other data that's coming off the ROV. So you could sit in this lounge, and there's a communication box. So you could call it to the control van and basically be immersed in the dive without being in the control van, which has limited space. Our social areas, that's one of my favorite things about this ship. Really, there's kind of build a family when you're out to sea on Nautilus, and having a social area like this where people like to gather to share meals and discuss the science that's going on is really important to that. And in the future, we're also improving our data spaces on the ship. So these are upcoming improvements for the 2014 season, which is going to start in June. We'll have a new data lab, which will be great. We're going to just have an all-new space there with a rack room that's going to move a lot of the electronics gear that's now in the control van down to the center of the ship. And then we're going to have a new control room, so that van that's on top of the ship is going to be completely rebuilt, and we're going to put our studio at the back of that room so that there's a sort of a CNN newsroom type view for people on the web able to see into what we're doing. This is our wet lab, the space where we process the samples that we collect. We have a microscope that you're able to connect up to a screen and send that out over the web. When we get samples up, we organize them and start processing them right away. This is our air conditioning right now. We're going to also hopefully improve that this season. We recently had a fume hood installed, which is a lab-grade fume hood, and that's been a huge improvement because in the past several seasons, we've primarily collected geological samples, and now we're able to do a lot more biological sampling and preservation. We were limited because we didn't have a safe space to deal with chemicals. One final neat feature of our ship is this moon pool that was put in, and so it's a hole that runs through the hull of the ship and has there's a winch up there. You could deploy any sensor that you want through that. We've used that for like USBL tracking when we had Sentry on board this summer. All of our samples and data, like I said, one of our goals is to get that out to scientists. or anyone that's interested in looking at it. So we put our data and our samples in repositories, and this is definitely an area where we're improving into in the future. Currently, all of our rock and core samples go to the Marine Geological Samples Lab, which is located at URI. Those samples are all searchable in an NGDC database. Our biological samples are going to the Museum of Comparative Zoology at Harvard, and then the tissue samples to the Ocean Genome Legacy, which is located at Northeastern University. And they're great because they already have these databases. You could search for Nautilus data. These are all our samples that have been put in. And for example, one of our fish here was a newly discovered species. They did a nice CT scan on it, and you could just go in and look at that data. Scientists can then request samples from these databases and actually, work with the samples to make discoveries. I'm working with NOAA right now as well to have our information put into their NOAA Digital Atlas, which is also going to increase the visibility of our data, and then people can request digital data from us. And in the future, we're also looking to get our multi-beam put into the NGDC database. So this is what the back deck, the working area of the ship looks like. Our main platforms for exploration are the two ROVs. This is Argus, the sort of underdog ROV. This is the one that just has some lights and cameras. It's really used to depress the cable between Argus and Hercules, so that Hercules, which is actually sitting on the seafloor doing sampling, and the close-up imaging can sit stable on the seafloor and do that work. So Argus here, it weighs 6,000 pounds and has an HD camera and a lot of lights to give a nice overview perspective. Personally, I like the camera view you get from Argus because as a geologist, it provides this nice landscape view. You can see a much larger area. And then Hercules, which has, and I should say, Argus is rated to 6,000 meters. Hercules is rated to 3,500 meters, or nominally 4,000 meters. We're limited by cable right now. There's these, heavily equipped for sampling here. We have all push cores along the side. This box is a box that comes out on hinges, and you could put however many samples you want to divide that up into. The front of the vehicle as well has some sonars on it for finding objects, and then more push cores. We could put Niskins on it. And again, scientists are always working with us to integrate new sensors and tools. There's a CTD on Hercules. There's also, of course, the manipulator arms that are useful for taking samples. The back of the vehicle, I'm not going to go too much into this. Chris Roman, who really is responsible for this imaging suite of sensors, is coming to talk in a couple weeks. But I do want to mention that we have the ability to do stereo imaging through these cameras, really high resolution multi-beam imaging. This is a 1375 Blue View, and also laser imaging of the seafloor. And his students are doing some really neat stuff, trying to detect diffuse flow from the seafloor using this laser line scanner. It casts basically a thin green line over the seafloor, and the perturbations in that can give you an idea of not only bathymetry, but then diffuse flow. And this is an example of one of the instruments that a scientist is integrated to capture bubbles that are escaping from the seafloor. These are some products that come from the imaging suite that's on the back of the Hercules. So this is the multi-beam image from a mud volcano off the coast of Turkey. And this is the same area, but this is the stitched together photo mosaic from the camera system. In the winter of 2013, we had an EM302 installed on the Nautilus, and Todd Gregory designed the blister for this. It has a couple extra spots. We have a USBL tracking system in one, and we have an empty spot for maybe something like an EK60 or another instrument to be installed in the future. But this has definitely revolutionized the way we can do exploration. We can now truly go places where there are no maps and locate an object of interest and dive on it safely. The components of the system, I just wanted to point those out. We have a CPAT that ties the MRU and the DGPS positioning together. All of this is, these electronics are located in this little sonar room down in the ship. There's a water pump that's measuring the sound velocity at the hull. And then we do our sound velocity corrections currently with an XBT system. This is just to show some of the kind of data products that we're using and how we're using the multi-beam data currently. So as I mentioned, we could go to a place that we didn't have good maps or we didn't have any maps, and we can determine the areas of interest and then accurately locate that target. And that had been a huge barrier to being efficient at being explorers in the past. Sometimes we would have maps that just weren't registered well, and we'd spend hours and hours looking for an object that maybe we'd never come across. Now our maps just, they work wonderfully for what we're doing. Using the backscatter data, a lot of times we're looking for hard bottom areas of interest, and so we use that to determine the best spots to dive. It's also important for situational awareness. Obviously, we're going to areas sometimes where there are high currents, so putting the ROVs in a dangerous spot, you want to know you have good maps. And finally, something we're really working towards in the future is putting these 3D renderings out over the web via our telepresence to give people better situational awareness, viewers, the public, a better idea of what we're doing. So we're working on getting models of the Hercules and Argus ROV into something like this flighter mouse scene and having it track real time where we are. And certainly when Larry's been out on the ship with us, that's been something we've done. So I wanted to talk a few minutes about how our first season having this multi-beam aboard has been for us, both the positives and the negatives. I think a huge positive was finding out how much people were going to use the multi-beam. We send out surveys to the lead scientists who are coming on board, and maybe they weren't sure how or if they even wanted to use the multi-beam when they were planning their cruise, but quickly they found that there were areas that they wanted to map when they were out there. So between ROV dives, we would usually turn the multi-beam system on and do some surveys for them. So we definitely mapped a lot over this last season. One of the difficulties of that for us was staffing. You definitely need trained people on the multi-beam, and for a ship that operates a lot on science interns and young people coming out, it's a challenge to keep our ship staffed for that kind of joint multi-beam and ROV operation. Another issue that I bring up just because I think a lot of you are multi-beam users and EM302 users potentially are the temperature problems that we had that plagued our system early on. We couldn't figure out why the system when we got to the Gulf of Mexico wasn't working. We did the sea trials for the system in the Mediterranean off the coast of France in April, and the system worked beautifully. We did a nice endurance test, had no problems. It got passed with flying colors by people here at CCOM and the folks from IFRMIR who helped us out. And then when we got to the Gulf, we got the red screen of death every couple hours. The system was locking up, and we were wondering, what were we doing wrong? Turns out the cabinet is packed a little tight there. There's a the power supply next to all the TX boards here, and we were actually overheating the system. We had a couple of we got a temperature logger, and we could see these spikes, these diurnal spikes of temperature in the sonar room. It never went out of spec, but it was hot enough to cause the TX boards to have to be reseated at times, and one of them eventually failed. So we have 2 AC installed in the sonar room now that keep it frosty, but that was definitely a big learning experience for us. Here's another sort of unresolved issue that we're going to test out this year or bring some engineers out to look at this sector outage, and that actually shows up in the point clouds of the data as well. So we have this starboard side sector outage that nobody could help us diagnose from shore. So again, a big part of our ship is getting all of the all the expeditions, all the exploration that we're doing out over the web. And so we rely on a satellite to do that. When it works, there's a rainbow over it. Everyone's happy. And this graphic kind of shows you. So from the seafloor, the ROVs are imaging things. That's being beamed up to the ship through this fiber optic cable, and then the satellite is sending that out to viewers all over the world who go to our Nautilus Live website and are able to watch it. It's also broadcast over internet too for people at these exploration command centers like you guys have here, which is great because that also has the communication boxes, so you can put on a headset and talk to us directly on the ship while we're on watch and tell us what to do, or you know, ask us a question. And so this is what the inside of our control van looks like. This is the back row where the scientists sit. We have a mapping spot or a guest spot to sit here. And then in the front row, we have the ROV pilots, a navigator who's in charge of moving the ship so that the ROVs can be in the correct position for the science team, a videographer who's doing all the zooming to get nice imagery, and then an educator who's communicating with the public and asking questions. So yeah, you might recognize Larry.
So which one was Larry? Was he the videographer?
Yeah, we enjoy having Larry out in the boat, and he's always the one in charge, telling us where to go, what to do. And then here's a view of the front row of the pilots. And this is just a shot of our webpage to show you. It's like there's a little participate tab here so that people who are just watching us from the web can actually type us questions and have them answered in real time. There are also some studios that we can broadcast from, and this is a studio that's located on the Nautilus. So the person that we bring out that's in sole responsibility as an educator or as a communicator, they broadcast live from the studio every 15 minutes from like 10 a.m. to 6 p.m. So it's a kind of rough schedule. There are 3 of them on the ship, but they're constantly doing shows with associated museums, aquariums, and science centers. And a lot of times they'll invite one of the scientists or ROV pilots in to do an interview with them and basically just interact with the public live. If the satellite's down, we can go to the Inner Space Center where there's a studio there, and they've also been working on producing more regular like news update type things to get people engaged more regularly with exploration. So who is the ship kind of run by? The Ocean Exploration Trust was founded by Bob Ballard and Katie Croft Bell. And since then, they've definitely expanded the team a lot in the last year. So we have an operations manager, someone who's in charge of education, data engineering, production. We have people like Dwight who help us out from the Inner Space Center doing interactions there. And then Chris Roman, who does the imaging for us, and some postdocs as well. The science objectives of the ship are driven in part by our science advisory board. So these are people who are already established in science and have really no dog in the fight, is what they like to say. So they're there to represent the best interests of the science community at large. They help us determine the best places to go to find something new, to answer some questions that people have about the seafloor or the ocean. And on the ship, we rely a lot on interns, students, from high school students through early career scientists. Those are the people who are our scientists, our navigators. We bring them out as ROV pilots. So there's definitely an opportunity to get involved. They learn how to process samples, how to take scientific observations, and I think it's a great experience. It's how I started, was as an intern with Nautilus. So some season highlights. I realized I would get to this point and not have too much time to talk about the science, so I wanted to point out that we publish every year a special issue of the Oceanography Supplement, and so there were a couple that I put out here. Our newest one was just put in press. If you go to their website, it's the Oceanography Society's website. The latest issue of that is up on their website right now. From 2009 to 2012, the Nautilus operated in the Black Sea and the Mediterranean, as far out as the Eastern Atlantic for a cruise. And then after having the multi-beam installed last winter and doing the sea trials off of Toulon, France, we transited across the Atlantic to the Gulf of Mexico. And so we've been, this past season was the Gulf of Mexico and the Caribbean, and this next upcoming season in 2014 is Gulf of Mexico and Caribbean as well. I wanted to give you an idea of what makes ocean exploration so different and so exciting compared to your normal sort of research cruises. I think in science, a new discovery can be made at any time, but this video that I'm going to show is sort of the epitome of what we do. And so what you're going to hear is a conversation between Steve Carey, who's the lead scientist for this cruise, this particular cruise, which was in the Mediterranean in 2011, and Brendan Phillips, one of our ROV pilots.
Oh, so I have a question from Ben in Atlanta. Ever see any World War II planes on the bottom? Brendan, you ever see
Seen one.
any planes? Yeah? What kind?
I don't know exactly what it was, but some images from way back. Also in 2006 in the Black Sea, just south of Ukraine.
In the Black Sea, yep.
Yeah, it was,
So Ben is asking about World War II planes. He served in the Air Force in the Second World War and flew B-17 bombers and flew some, I believe, if I'm correct, Ben flew some back from the Western Pacific back to the United
just
States.
trying to get an eyeball on it, so I might stretch you out. Yeah, what is that?
Oh.
Oh my God, are you kidding me?
What is it?
Speak of the devil.
It's a plane. Ben, are you watching this? My God, I don't believe this.
Katie.
Drop up target here.
Wow. What?
Oh, this is too spooky.
That
Is this spooky or is this spooky? Ben, are you watching this?
All right, let's go a little bit north.
Oh my God, I can't believe this
Well, let's
happened.
just see what the ship slides.
I cannot believe this happened.
I can't.
That is absolutely bizarre.
This section right here is pretty telling.
I don't see any
I'll bet you.
propeller.
Yeah, no, I don't either. See the
Can we get a
ripples
little-
at the
can we get a little zoom in?
Oh, sure. Can we get a zoom in on that shrimp? Just trying to
This
flip
area
up.
right in here, I bet is really telling.
Yeah, I would think it. I would think so. I'm pretty sure those were gun.
Yeah.
But where was the?
Yeah, let's get some good
Is that a
screenshots right in there.
Where's the
That
cockpit?
magnificent area.
It's probably the black box, what do you think?
I don't think it's black box.
No, not on these guys.
That is the gun.
Oh,
Yeah.
it is.
Yeah, that's right.
Two of them. Right
Yep,
there.
I see them.
Oh,
Yeah,
yeah.
yeah.
They're cool. You can see
It's
the
the fire.
flying things.
Yeah.
The guns.
Uh-huh.
Want to get a zoom in on that
Does it look?
marking?
Does it look German?
Almost have to be.
Does it look like a German?
Swastika.
What is
No,
that?
not a swastika, but
That sounds cool.
okay. There's
Oh,
some
that's
people.
Little corals.
Okay, we got some stuff coming in from the website. That is an Italian Air Force marking. The plane looks like a Macchi, M-A-C-C-H-I.
Okay, let's zoom out.
So it's definitely a World War II plane?
Yeah, World War II.
This is crazy.
That's good.
So for me, that is a truly incredible moment because it shows how important the interaction with the audience is as well for us. So why that telepresence is important. You know, we came across this object that was, you know, just serendipitously an airplane, but the fact that someone could identify that marking and tell us right away what it is, and this happens with other things as well. The next slide has an example of that I'll kind of narrate a little bit. But so we do some research here in the Mediterranean. This is the crater of Santorini, the sort of stuff that we were doing in the past. We've hidden from storms behind an active volcano. This is Stromboli. This is just some fun images I want to show, but this is the one that gets at another way that telepresence has helped us in a sort of more scientific way. We came across this on the Seamount Eratosthenes in 2012. We were just cruising over with the ROVs in what's called tow mode. So the ROVs are about 10 meters off the seafloor, and the ship's kind of just towing them along. We were trying to get from point A to point B, and we cruised over this, and we were like, wow, what is that? So we stopped the ship, turn it around, and go take a closer look. And Larry was actually out for this one. Larry and Bob were in the control van right away trying to figure out what this was. It was, I think Larry said, Al Hine, who was watching remotely via telepresence, who said that's a whale skeleton. And so we took a sample, and the center of the bone was actually not fossilized, so we've sent that to Smithsonian, and they're having a look at it. So it's just times like this where you're not expecting to find something and you do. That's kind of neat. Another example of this from the Eratosthenes trip, these columnar formations we thought maybe were something like a columnar basalt, but when we were able to take a sample again, it was like a limestone, a calcareous rock inside, so they were cairns, which are formed by dissolution, something completely different from what we expected. This Athena mud volcano is just south of Turkey in the Anaximander seamounts, and was a volcano that by all research that had been done, which was acoustic research from the surface, nobody had ever taken a look at it, was supposed to be a really quiet, dormant mud volcano, and it was one of the most active and interesting, just these chaotic formations of these carbonate crusts that we had found after looking at 7 different mud volcanoes on the Anaximander seamount. So it's really neat to be able to put your eyes on something that nobody's seen before and make a new discovery like that. Sort of a area of interest that's followed us, or a question that's followed us across the Atlantic, these what we're calling beaked whale scour marks. That's what scientists have attributed them to, but it's never been seen that these beaked whales are actually leaving these marks. But they're found all over flat areas of the seafloor. The beaked whale is a deep diving toothed whale, and we've seen these in the Mediterranean between 800 and 2,050 meters water depth. We also see them a lot in the Caribbean, but we don't know why, if the beaked whale is doing this, why they're doing it. And we could see this as a photo mosaic of a 35 by about 35 meter area. The whale seems to return to the same area, not the same whale, but decade after decade, because some of these are filled with pteropod shells to a greater degree, so you could tell some have been filled in more than others. So it's a really interesting question. Here are possibly beaked whale marks in our towed side scan sonar that was on Argus, who was pretty close to the seabed. One of the discoveries that we made this year that was unexpected in off a little island in the Lesser Antilles here was this debris avalanche, which was expected to be mud. So the the volcano CCOM-JHC was the area we were really going to explore. It's a submarine volcano off of this Rhone island here. And we mapped this area, and Steve Carey, who was our lead scientist, saw this debris avalanche and wanted to go take a look. We had a National Geographic film crew on board, but they wanted to go film some stuff around the island, so we sent them to shore saying, oh, this is going to be all mud, it's going to be boring, no need, don't worry. And it was the most incredible dive probably of the season because it was so unexpected. All of this is bacterial mat, the white here. This is, again, a photo mosaic that Chris's team made of this debris avalanche. And it had the most incredible biological communities on it. So it had these boomerang scallops. They're as long as your forearm, 30 centimeters long, giant, giant mussels and scallops down there. So we were able to sample that and send it to the scientists who are studying it now. But again, it was just something totally unexpected that now we're able to give that data to scientists who can go back there and do more studies on why this methane seep exists in this area. So to give you an overview of the areas that we've been in the Caribbean, These areas were chosen by the scientific community. So we put out a call for white papers from interested scientists who wanted to explore the Caribbean and Gulf of Mexico region. And we had a meeting in Miami back in 2012, the fall of 2012, and we came up with these boxes by the end of the meeting that were the areas of interest from biologists, geologists, physical oceanographers, archaeologists. These were the areas that they chose as unexplored, unknown, or having the potential to answer some really interesting questions about hazards or tectonics, or we were looking at the connectivity between the Atlantic and Caribbean region. And so these dots show the areas that we've been to, the white ones in 2013, the red ones are areas we're going to in 2014. So we're covering a lot of those areas with our cruises, and then by next year, we're hoping to finish up our time in the Caribbean by going to work with the people in Colombia a little bit, possibly in Mexican waters on the Campeche Bank. And then we're gonna hopefully move through the Panama Canal midway through our 2015 season and begin our exploration in the Pacific Ocean in 2016. So this is where I invite all of you guys who are interested in exploration in the Pacific to look at our website, the oceanexplorationtrust.org website, for a call for papers for the Pacific region. I'm going to be co-chairing a meeting right before AGU in December of this year with Katie Croftbell to do just what we did for the Caribbean planning meeting. We'll solicit papers from the scientific community and invite all those people to come. And it's really a nice sort of informal meeting. You don't have to give a presentation. It's really getting together with fellow scientists and coming up with what the important questions are for this. Probably we'll start with the Eastern Pacific region and what areas we should go to address those questions. Other opportunities, I encourage everyone who knows someone who's interested in going out to sea in any way to look at the Ocean Exploration Trust website. We bring out middle school students as Argonauts, high school rising juniors or people who are going to be seniors with our honors research program, and then undergraduate through early career scientists through our science internships and engineering internships, video internships as well. You could also participate from shore if you'd like by becoming a scientist on shore, and that is something where if you email me at my email address here, I'll put you on a list, and then we'll send you a form and you can fill it out and let us know what cruises you're interested in and perhaps what kind of data or samples you're interested in, and we'll include you on those cruises as best we can. We have a science chat function so that you can go to your geo room here, the telepresence room here, and watch us and type in your science comments and help participate from shore. Ethan, who's our data engineer, is looking for an assistant, so we have a data engineering position open right now. And again, I encourage anyone who's interested to participate in this Pacific Planning Conference. So with that, thank you, and I hope to sail with you guys someday.
Let me just make a comment. If you have that lead mapper navigation position, explain that we here at the center have an agreement with whatever you're calling it, Ocean Trust, Ocean Exploration Trust. I never can keep track of the different names of the organization, where we provide, when they needed help with particularly mapping positions, but now also navigating positions. And it's actually a little different because most positions actually get paid going on board. And so we've drawn from a number of our graduate students in the past, and so with everybody here, I want to emphasize that that opportunity exists. This summer's program, there's lots of openings from basically around mid-July to the end of September. So if you have a few weeks or a month or any kind of time period that you're interested in the experience at sea, and you think you can basically, what they'll call upon you to do is do some CARIS processing, some Fleet Mouse processing, stuff you mostly all have done before, and then they'll train you for the navigating position, which is a really quite exciting position. Let me know, and we'll get in touch with Nicole, and we'll set up a schedule. We've had lots of our folks have gone before, and there's room for many more.
So in this room, Kevin has done this, Matt has done this.
Well,
Chris has done it.
Lindsay did it, Chris has done it, and they can tell you about it, and you can go again, too. You're not taken off the list unless you did bad. And even the old people can go too.
And Larry's our lead scientist on our first cruise this year in the Straits of Florida and Bahamas. So. Any questions? Yes.
How many people are typically watching online at any one time? I just find it interesting that like somebody was able to, they might have just looked up the insignia, but like that you'd actually have someone who happened to know what that plane was or that kind of thing. What's the typical viewership?
I couldn't say what the typical viewership is. I don't personally keep track of those numbers or have those numbers. We do have people who are tracking that kind of stuff now, but I can say we gain an intense regional group of followers when we go places. We have our people who are always writing in from the States. We have like a sort of a loyal fan base here, but wherever we go, in the Mediterranean, obviously you could tell there it was a local person from the region writing in. When we were off of Puerto Rico, we do some open houses down there, and that generates just huge interest. We have a lot of Spanish-speaking people that we had writing in. And luckily, we also always engage local scientists, so we usually reserve 1 or 2 spots on the ship for the scientists of the country whose waters we're working in, and they'll come out. And in that case, for Puerto Rico, it was really helpful for translating what we were doing to the local people.
Nicole, it's probably safe to say that there are thousands of people
Yes.
joining in. And when they do the Nautilus live shows, which involve the boys clubs and girls clubs, it's tens of thousands, if not hundreds of thousands.
Yes.
It's a very large web-based presence.
All right, well, thanks, everyone.